Hello, everybody, and thank you for joining us today for Vertica Unify 2021. Today's breakout session is entitled Advanced Security Topics in Vertica. I'm Jeff Healy, and I lead marketing at Vertica. I'll be your host for this breakout session. Joining me today is Fen Fox and Chris Morris, security software engineers on our R&D team. Before we begin, I encourage you to submit questions during the virtual session. You don't have to wait, just enter your questions into the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions that we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded and will be available to view on demand this week. We'll send you a notification as soon as it's ready. Please stick around to get the code to gain points to participate in our Analyze to Win competition and win prizes. Now let's get started. Over to you, Chris.
Thanks, Jeff. Thanks, everybody, for joining us in our talk here, as Jeff said, in Advanced Security Topics in Vertica. My name's Chris, and I'll be joined by my security team lead, Fen. So in this talk, we'll be building on the basics from the general security talk. And we'll assume some familiarity with security topics and expert. Don't worry, we don't expect you to be an expert on this stuff, but it would help to have seen that talk. So the in-depth topics for discussion today, I'll be talking a bit about how inherited permissions work with views and some use cases around that. And then Fen will follow up with some interesting information about how Vertica handles data in transit, encryption, and protection. And finally, we'll wrap up with a bit about where security is headed in Vertica. Inherited privileges and view dependencies. Well, this is a topic I've seen crop up a few times with customers. It can be tricky to get right, even though it can be really useful once it is set up. We'll be looking into the mechanics of how this works, so hopefully you'll be able to effectively adapt it to your own use case. But before we get right into that, I do want to do a quick refresher on just some of the permissions basics in Vertica. So Vertica is a discretionary access control system, or a DAC. And what that means is that principals, i.e. users, can grant privileges down the chain. That's opposed to a system where all permissions are expressed by a purely centrally managed set of rules. The consequence of this is that privileges originate with object owners, and they can be granted downstream. So if you're familiar with a little bit of math, what you end up with is called a DAG, or a directed acyclical graph. And there's some rules about that. You can't create a cycle. Well, what's a cycle? A cycle, we'll take a look at it in a second. It's when the graph points back to a node that's traversed earlier. So what that means in the context of Vertica's privileges is, let's say Alice grants privileges to Bob. That forms like an arrow from Alice to Bob of privileges. We can't have an arrow go back from Bob to Alice, so Bob can't grant privileges back. You may have seen, if you've looked in Vertica's system tables or done any privileges grants yourself, something called a grant option. So a grant option is what determines the ability to grant privileges downstream. So the normal privileges like select and insert all have a corresponding grant option that the owner starts with. The owner always has it implicitly and can optionally grant it downstream along with the regular privilege. So when an operation requiring privileges is initiated, like a query, what happens under the hood is that the initiating user, and possibly others, as we'll see, have their privileges checked against each object involved. What happens is that DAG, the graph of privileges, of grantor to grantee to grantee, is turned into an access control list, or ACL. And when the queries run, that ACL is scanned by the privilege checker code. All the principals are included at that time, and the privileges for the relevant principals are collated as part of the scan until the privileges required for the operation are found. And either it succeeds and short circuits, or it tells you, nope, you don't have the privileges to do this. So those are the basic privileges. And here you can see this DAG that I was talking about, the graph. So imagine Alice owns, for example, a table. Alice grants select to Charlie, so Charlie can select on it, but Alice chooses to instead give select with a grant option, noted with the asterisk here, and that's how it will show up in relevant system tables in Vertica. Alice grants that to Bob, and that lets Bob grant it further downstream to Dan, whereas Charlie cannot do that. And you'll see in the upper right a little X'd off arrow. And what's that showing is that Dan can't give privileges to Bob because that creates a circle in the graph. It's not super important for this, but technical reason for why we can't do that sort of thing, in part, is if Bob got his privileges revoked, we'd end up with a nasty little circle, or an orphan privileges potentially. But be that as it may, let's move on to inherited privileges. Inherited privileges let you manage privileges for whole schemas at a time. So a subtle note about this, first off, if you've used some of the SQL commands or DDL around these objects, tables, and views, you may have seen that you can actually alter a relation individually, and that the schema command actually just says, I believe, default include privileges. So this inheritance is actually a property of relations. You are allowed to have some relations, being user tables, inheriting privileges in a schema and others not. That being said, I definitely would recommend not mixing and matching and turning inheritance on for all or nothing for some simplicity of management. But don't depend on that default include, just altering a schema once. If you've already got tables or views in that schema, you'll need to go back and alter those. But newly created ones will automatically pick up that inheritance. So what does it mean, these inherited privileges? Well, let's say I've granted something on the schema, like select, and I've also got a table and said schema with inheritance turned on. When the ACL, the access control list, is constructed for that relation as part of the privilege checking, the schema grant with select is copied on just as if it was a grant on the object in question. And so that scanning, when it gets to the point of scanning the ACL, it sees it as identical to the direct privileges on the object. At that point, there's no difference. This feature works for tables and views. You can inherit privileges for both of those objects. Tables, it's pretty straightforward, and views, it's a little less straightforward, as we will see. But this is just a visual representation of what's going on here. You can see in the upper left an example grant statement. Grant usage select on schema cells to salespeople. For the schema usage, you have usage, which of course makes sense. Select doesn't particularly make sense by itself, but once it's applied to that table, because the sales.foo, for example, has inheritance turned on, now that grant actually gives select on table foo to salespeople. And the ACL entry for that is on the right. You'll see the entry number 1, which is the owner's self grant, which has all privileges, and then entry 2, where the owner has granted the select to salespeople. And the final background piece here, some view privileges. Well, your own views are simple. For our purposes here, all you're really doing is creating a cached select query definition on any table or views you have access to. And that's what you're allowed to do. You can just create it. But grants on views are tricky if you want to start giving privileges to other people to look at your view or other principals. Granting select on your view to someone else, and this is the reason why it's a little tricky, is potentially the same as granting select on the original table. It's not necessarily, right? Often when we make views, we might be creating a view to hide certain sensitive columns, or when you're granting on a view, it is only giving you privileges on that view. But in the maximal case, you can define a view as select star on whatever, right? And so you could, in that case, be essentially passing through, in a sense, select on the original table. And that leads us to our special requirement for views, which is that you have to have, as the view owner, the grant option for select on all directly referenced relations. So any relation that shows up in that cache query, you must have that grant option for select in order not to select yourself. You can select on your view yourself without it, but in order to grant that select privilege downstream to someone else and extend that graph of privileges. So you might think, why do you have to do this? Well, the alternative would be to recursively expand the view definition until there aren't any views left, and then check everything, check the querier's privileges on every single object in the fully expanded definition. That is slow, complicated. We did not go with that route. We've gone with this route since the beginning, really. And because it lets us, again, if you're familiar with a little math, it lets us achieve the requirements of that privilege graph by induction. If and only if Alice can grant the grant option for select and select as well on her view to Bob, she has appropriate privileges on the reference relations. And Bob can do the same on a view he creates, and so on and so on. It's not particularly important to understand every step of this, but the main idea here is that the intent of allowing another principal to grant data access downstream is always explicit. with that grant option, we know that the person who owns the data did mean for the person they gave access to be able to pass it along. So this is an example view privileges check. So Alice owns the table foo. Alice grants select on foo to Bob with the grant option. Without that grant option, Bob actually can create the view bar as select star from foo. But with that grant option, Bob can then further grant select on bar to Charlie, and Charlie can run select star from bar without any problems. If after the fact Alice revokes that grant option from Bob, the view bar will actually stay okay, but Charlie's query will start failing. But that grant option from Alice is important because otherwise Bob could pass on select access to foo via bar without Alice intending it. So this makes it quite clear Alice meant for Bob to be able to let Charlie select on this thing. So some advanced use cases putting this all together. Well, normally it's the responsibility of a view creator to set up privileges appropriately, like creation time or whenever a view changes or when privileges should change. Maybe you've added a new user to the system. And in an ad hoc basis, this can and probably should be done without inherited privileges, just with direct privileges. So grant whatever privilege you want directly on that table or view. But as with tables, it's often useful to manage views in batches. So let's look at some use cases that might lead us to that approach. So there are two, I would say, kind of sets of use cases here. The first one, it really comes in a lot of flavors, but you've got one schema, or more likely many schemas, where a certain set of principles has the same privileges on everything inside of it. Now these schema or schemas might be different in what they contain. Views might be constantly created and destroyed. The tables might be stable, like just kind of dimension tables that always exist, or they might be created and destroyed themselves. They might be in the same schema with the views. They might be in a different one. You also probably have more than one set of principles involved, and with each of these sets of principles should have different access levels. So they shouldn't see all the same data. For one big example of this would be where you've got one set of principles that should be allowed to create views and another that should be just able to select on the views. And definitely in one case, the set that it will be creating views needs privileges on these base relations, but the set of principles that is only selecting on the views, they only ever need privileges on the views themselves. So we'll take a look at some of those. But the second use case, which differs a little bit from that, although in practice it boils down to something similar, is that everyone in the database should see everything. Basically, no privileges requirements. It might not be the greatest idea, but sometimes your threat model doesn't require segregating data access, and that's totally okay. So we want to make this setup work as well, even though it's not necessarily something we were designed to do. Well, how do we meet these use cases? Both sets of requirements look like a pretty good use case for inherited privileges. And the reason for that is we're making privileged decisions about large groups of views, which may come and go, but all these views should have the same access controls. So we don't want to constantly be issuing grants to every single principal in the database every time we create a new view. That's a huge pain. We just want to create a view and have the privileges be set up the way we want. And it should be set up just like every other view in the schema. So inherited privileges, just grant on the schema and you're good to go. Well, unfortunately, it's not as simple as you might think. So you might think that just granting select alone on a schema to a role, or maybe even to public, would let you see everything in that schema with inheritance turned on. So if you remember that inheritance is something that is turned on for an individual relation. But there are some features of the permission system that are relevant here that prevent this from working. They are important. So the first one we'll be looking at is you've got to meet the view grant option requirement, which I've mentioned earlier. We'll take a look at a little closer. The second is not a hard requirement, but is a very strong recommendation, is that you'll need to think about where the underlying tables and views, underlying meaning referenced by views, where are they located and how should they be grouped? And then finally, we'll want to work with roles and set them up properly while keeping some restrictions in mind. And once all of these pieces of the puzzle are put together, then we've got our solution. The first piece is the view grant option requirement. So with inherited privileges on for each relation and select granted to a shared role on the schema, users might technically have select on all relations in the schema. So in this setup here, if you looked in the inherited privileges system table, you would actually see that Charlie has select on bar. Well, why is that? There's nothing special required to grant select on a schema to a principal. There's no dependency requirement. It just checks that you are allowed to do that based on possessing the grant option for select for that schema, and it just happens. But just because we do that doesn't mean that the grant option requirement goes away for any views in that schema. So why can't Charlie select from bar here? Well, Charlie's a salesperson. Charlie can actually select from foo, but if Charlie selects from bar, it won't work. And that's because Bob must have the grant option for select on foo. He's got to get it somehow. He didn't get it from salespeople. So I mentioned that if you look at the system table, inherited privileges, or if you wanted to look at the grant system table, we'll show you other stuff. Those will show Charlie is having select through the role. But if you run the function get privileges description, that will actually do exactly the same runtime checking that any query would. And that will show that Charlie, in fact, does not get the select. It is nullified by virtue of this dependency check failing. We still need to satisfy the properties of induction to prevent unintended data exposure. You might think here it's harmless, and it is in this particular case. It would be harmless to relax the requirement about this grant option because we can say, hey, Charlie can select on everything that's part of this view definition, so why can't we just call it good? Well, it turns out that if that was a general rule, if we generalize that, there are some trivial exploits that allow you to bypass that original intent I mentioned, the intent that the object owner and anyone else granting privileges knows that they are allowing further principals downstream potentially to see it or not. Here we've got a little more complicated situation. In the previous one we saw where everything referenced by that view was in the same schema. But in this one here, we've got a view bar, which is referencing things in multiple schemas, which is really quite common. But it's an additional thing we have to consider. Does the view owner have grant options on the things that are outside of this shared schema where the views live? You can see here that Bob is a member of the analysts group, so he has the analyst role. And analysts on the schema analytics, they actually have the grant option for select. So in the view definition, where it's selecting from fizz, it will actually pass that dependency check with a caveat we'll get into later, but it succeeds a dependency check for that particular object, fizz. But because it's also selecting on something in a different schema, and Bob in that schema only has select, even if inheritance is turned on for foo, let's assume it is, Bob has no grant option for select, and therefore Charlie will still not be able to select on bar successfully. And the solution here is just to make sure Bob has that grant option for foo. And in this case, Charlie, again with a caveat we will get into, would be able to select on this view now. But now we've just given one grant to Bob. This isn't particularly scalable, right? How can we do this in a manageable way, in a way that does scale? So that is really the whole point of inherited privileges. Well, the first part of this, second piece of all the pieces, is managing your base relation privileges. I'll preface this by saying that I work with security stuff, and I know that there are many constraints and concerns going into schema design, most of which I am probably not aware of. But from the perspective of privilege management, the best advice I can give you is to keep your schemas clean. You don't want to have something like you see on the right, where you've got this grab bag schema. It's got, as an example, a really important confidential table in it, and then potentially also a commonly used dimension table. Now, the consequence of setting things up like this is that you'll never be able to turn inheritance on for both of these relations and give a single grant on a schema to a user or group that makes sense. You've now forced yourself to manage the privileges individually. So a sane schema setup is where all your base relations for the views that you're going to be creating are in some set of schemas and not mixed up with other relations which should have different privileges. So things should be roughly grouped by what kind of access controls should be on them. And that lets us manage these base relation privileges on a group level. Otherwise, management is just a headache. It's much easier to turn on inheritance for all relations in the schema and just forget about managing individual relation privileges. not only is it about the relations, but when the schemas are uniform, we can address the privileges by group of principal, as in Vertica roles are how we do that. So hearkening back to those earlier classes of use cases I mentioned, in the first use case where we've already got different sets of users potentially with different permission levels, what can we do here when we've got our schemas set up in a uniform way? We can grant the grant option for select on appropriate schemas to the appropriate roles. In the use case two, where we just want everyone to select on everything and we kind of just want to get around all this privilege stuff, it's a little trickier because public has some restrictions, public being the special role named public, and we'll get into that later. So the exact approach differs a little bit by use case. And the key question, which we'll be looking at in a little bit, is how do we get privileges from these roles? But before we get into that, I do want to just give an example of what I think is good schema organization from the perspective of privilege management. And the main thing here is that the dynamic schema where all of your views are being created and destroyed when you want to turn inherited privileges on for, it's segregated from all of the sources of its data. So it may be that views are built on top of views, hence the little arrow looping back to itself, but also it's pulling from tables and views in other schemas. And each of these schemas differs by what kind of table is in it. By what kind of, I mean, not exactly what kind of data it contains, but rather what's the lifetime of it and what are the privileges on or that should be on those tables. You might have a schema with some sensitive stuff. You might have a schema with some even more sensitive stuff. The point being is you want to give one grant for each role on that schema. And so everything with differing privilege levels should not be together. And that lets us avoid a nasty scenario where we've got all sorts of arrows pointing back and forth. To the role requirements, we want to get it so we can just give one grant per schema per role. Well, because of the complicated nature of view privileges, because of that dependency requirement, certain arcane but important properties of roles become relevant here. Granting a role that contains privileges for a schema, it's necessary, but it's not necessarily sufficient. And the reason being is if you've ever messed around with roles in Vertica, you'll notice that when you start a session, when you log in, you need to use the set role command to turn it on or off. If the role is off, then you don't actually have any of the privileges from that role. But because we're checking privileges of view owners as part of queries on views, view owner privileges must always be active. So how can we make it so that roles are always active? Well, Vertica has a way to do that. It's called default roles. Now, how do you activate these roles? How do you set them default properly? Well, in our first use case where we've already got really roles, right? We've got sets of principals which should map one-to-one to roles. They may be overlapping, of course, but it's pretty easy to set this up. In fact, it's trivially scriptable. Just make sure that the appropriate users have their shared role set as default. Ideally, as part of your user creation script, if you've got one, just add an extra line, alter user default role, and boom, you're done. And the second use case where we want all the privileges to be part of public, well, unfortunately, public has some special rules and we can't use it for this. It's not particularly important to understand why public can't work here, but for the sake of curiosity, public can't have grant options. It breaks the acyclical nature of the privilege graph and some other optimizations that are built into the privileges checking. And then additionally, another restriction is that roles assigned to public aren't implicitly defaults, which differs from every other role. Normally, if I possess a role and that role further possesses a role, simply turning on the first role turns on any other roles in that chain. With public, it doesn't work that way. And you can't set those rules as default for a user. Those are the technical reasons for all that. The important consequence that we actually care about is that we need a workaround. Fortunately, the workaround is very easy. It is simply to make your own quote unquote public role and then just script granting it and setting it as default for all your new users. So on the right here, just this was about the first point. So when Alice is an active user, Alice can set role salespeople to have it as active. But as a view owner, they're logged out. They're not part of a session. They haven't done that. So their active roles are none. But by using that alter user default role, we can make it so that in both of those situations, Alice does have that salespeople role as active. Putting it all together, it turns out it's not really all that bad, despite all the complexity underlying it. There's a few steps. The first step, run it once per database or Basically, you may run it after your database is created, of course, if your privileges or permissions requirements change, if your access control situation changes, but you only need to do it as a once off. So on the right there, create a couple roles. And then once per schema, you want to alter the schema to default include schema privileges, remembering that that doesn't change any existing relations, so you'll need to alter those as well to include schema privileges. And then grant usage, of course, but also select and the grant option for select to the relevant roles. So the creator on the right who will be making the views needs that select with grant option on both the schema analysis where views will be created and DT, like a dimension table schema, to pull from that. Whereas reader only needs the select on analysis. They only care about privileges on the views. It's the view owner that needs special privs. And this is just something you just need to run once per schema. And finally, once per user, whenever you create a new one, just make sure you've granted the correct role and altered the user's default role. So when it's all said and done, it's fairly simple. It's not that the solution is complicated. It's just that there are a few ways to screw it up. So thanks everyone for bearing with me through what is definitely a complex topic under the hood. We'll be taking questions at the end. And for now, I'll be passing it off to Fen, who will be going in depth into Vertica encryption in transit.
Thanks, Chris. I'm here to talk a little bit about how Vertica protects data while it's in transit. And what do I mean by that? Well, Vertica makes a lot of network connections. First off, you have clients like vSQL or JDBC or ODBC or any of our various open source clients connecting to Vertica to query data. You have nodes communicating within the cluster, both through spread to transmit metadata, catalog contents and stuff, and nodes communicating between each other. You also have, using import-export, you could move a cluster from on-prem to Eon, or move between Eon clusters using import-export. And finally, although we won't be talking about them much today, you also have the connections that Vertica makes to third parties like Kafka, Hadoop, and S3. So first off, let's dive a little bit into what transport layer security is. This is kind of a high-level diagram of how it works, but the important takeaways are that everything except for the last two arrows is secured using certificates. So in this case, the Vertica server presents a server certificate that the client can use to encrypt anything it needs to tell the server, only wants the server to know. And the thing about certificates is that certificates use asymmetric key encryption. So the client just has to know the server's public key, and then it can encrypt data and send it to the server, who will be able to decrypt it with the server's private key. This works great, except that it's very slow. So in this case, once we get down to application data being transmitted, the client and the server have established a session key that they can use to encrypt application data using symmetric key encryption. And that is much faster than using asymmetric. So first off, the first connection that we talked about was clients connecting to Vertica. Clients create a TCP connection as usual, but then the Vertica server might not be configured to use TLS. So the clients can be configured to request TLS access. If the server responds with yes, then the client proceeds with the TLS handshake. If the server responds with no, then depending on the client's configuration, JDBC, vSQL, and ODBC all have a TLS mode that you can set to disallow plain text connections. Then the client will just give up. Additionally, the server can also enforce that the client connects using TLS, but that's using auth methods, and we won't be talking about that today. How you configure client TLS connections changed in 11.0. Here you can see this example goes over how to set up keys for an entirely new database. You don't have any existing keys or certs. You want to secure Vertica, and we've made it much easier to do that all using SQL. You don't need to run OpenSSL commands and then import those certs into Vertica. You can just run SQL and you'll get a database that can be connected to using TLS. If you already have a bunch of keys and certs and you want to keep using those, well, you can do that as well. You create key and create certificate as, and then the string that is the key or assert. Next, let's go over how we encrypt spread. So the issue is that spread is UDP and TLS requires TCP. So we can't just use TLS. Well, what we can do is use AES, which is symmetric key encryption. That means that every node has to have the same key, which is a problem because now we need every node to know the same key without ever sending it in plain text. Well, we have admin tools. Admin tools distributes many things to every node over SSH. So we can just use admin tools to move a key that it generates on one node to every other node. Admin tools generates a 256-bit key, which is 256 random bits, and then distributes it to every node at startup and restart. And so this happens every time you start or restart a cluster. There's currently no way to change the symmetric key while the database is running. So now you can see that every node has the same key, and now we can add AES to the UDP over spread. We just encrypt the payload of all the spread packets, and voila, we're done. So spread is encrypted, but that's just metadata. How about internode encryption? Well, those are TCP connections, and so we can simply have every node set up a TLS connection. Every node gets configured with a CA to verify that other nodes have a cert that they should be trusting, and a certificate themselves. And so that certificate is treated as both a server and a client cert. Every node uses the same cert to present as the certificate to other nodes so that they can trust them. And that goes both ways, when connecting as a client and when being connected to as a server. So finally, import-export. Luckily, import-export uses both the client protocol and the internode protocol. And so it's easy enough to make this work. As you can see here, the client connects to Vertica using TLS or not. And then when you run a connect to Vertica command, cluster 1 connects to cluster 2 as if it were a client, like vSQL or whatever. When you run export to Vertica, instead, the cluster 1 sends a send export request, which is using the reflection protocol. And so then both clusters just connect using the reflection protocol. That's it for how Vertica encrypts your data in transit. But before we leave, I want to go into a little bit about what's new in 10.1.1 and 11, and also a little bit about where we're headed going forward. So we have a bunch of new features and improvements in 10.1.1 and 11. You've seen one of them already, the improvements to configuring TLS connections. Also, FIPS support has returned. FIPS is the Federal Information Protection Standard and is useful for, if you don't know, for customers or OEMs who want to sell into the US government. We dropped FIPS support because the most recent version of OpenSSL that was validated for FIPS was going end of life, and we figured that it was better to have a version of OpenSSL that was supported than to put all of our customers at risk by continuing to use it. Thankfully, Red Hat has done the work to validate their OS along with OpenSSL, and so we can once again support FIPS. We've made a bunch of improvements to the voltage integration. That includes adding more and different ways to encrypt data, and also we fixed the way that voltage interacts with access policies, so that you can now do DML on a column that is encrypted at rest and which voltage decrypts. And then finally, we have better support for configuring multiple S3 buckets with different keys and enabling some of the more complex use cases around that. And then finally, where are we headed? Well, some of that depends on what customers want, like you. But these are our broad overviews of stuff that we're going to work on. So first off is ease of use. We want to make Vertica easy to set up so that you're incentivized to set up a secure Vertica and limit the possibility of any data breaches or unauthorized users logging in. Secondly, we want to continue supporting the existing things that we have. We want to make them better. And then finally, we're working on native Vertica encryption at rest. And that means we support voltage, and that's great for many use cases. It's very flexible. The format preserving nature of it is advantageous to many customers. But we also know that some customers want in-database encryption at rest that is native. And so we're working on that. one final thing that isn't on the slide, but is a customer request that came in relatively recently, is that we're going to support OAuth 2 as an authentication method to allow more and varied single sign-on use cases. And now, back to you, Jeff.
Thank you for listening to our presentation. Now we're ready for Q&A. Fan and Chris, nice job with the presentation. To our attendees, we've gotten a few questions that have come in. So we're going to dig right in, and if you have a question that you want to pose, don't forget to enter it. Let's go for it, though. All right, top vote getter so far for the questions. Here's one. If I try to set up inherited privileges on views with roles, but my user can't create views, what are some troubleshooting steps? Fan or Chris, who wants to take that one?
I can take it. So if they can't create views, that's kind of step one. At that point, we don't even have, we haven't even reached the situation where users, other users are able to select on this view, right? So I would recommend just starting with the absolute basics. So it's just a checklist, right? So the first thing we need to create views, of course, is create privileges on the appropriate schema. So I would check the grant system table for the schema. I would also check the, that'll do it. So I would check the grants system table. Make sure, again, we're dealing with roles, right? So I would check that that user has the appropriate roles enabled, so you can look at the roles system table for that as well. If you can use a show role command. Once you verify that the user is getting create and that the role that they're getting create through is activated if necessary, then we know there's some problems with the base relations, right? So the schema itself that we're putting the view in isn't the problem. We, for some reason, don't have select on the underlying relations. So the first thing to do is look at the view definition, right? So take a look at every view which is referenced, or every table that is referenced in that view definition, and go ahead and look in the grants and the inherited privileges system tables, and make sure that the appropriate privileges show up in either one of those, right? Since we're doing it with inherited privileges, hopefully it'll show up in inherited privileges. And if it doesn't, that means it could mean a couple of things. The first thing it could mean is that the relation doesn't have inheritance turned on. That's pretty basic, right? So go ahead and check the inheriting objects system table. That'll tell you, any object that has inheritance turned on, it'll be there. If it's not there, that's the problem. But if it's there, then it could mean that you just don't have the right grant on the schema. So then go ahead, look at the grants on that schema for the base relation, again, the table or view we're trying to make the view on top of. Check that the grant exists for the appropriate role or the appropriate user. And if it does, then it probably means that the user doesn't have, if it's coming through a role, for example, the privilege on those base relations, it probably means that user doesn't have that role enabled. And that's pretty much everything that can go wrong, I think. Maybe there's some weird edge cases I can't think of off the top of my head, but those are the main things. I guess the basic advice would be to check the view system tables, check the grant system tables, check the inherited permission system tables, make sure that it all lines up, and just check off those boxes for each piece of the puzzle.
Great detailed response, Chris. I'm sure our audience appreciates that. Okay, we've got a few more that have come in, so let's go for it. The next one is, what key sizes does Vertica use? Fan, are you taking that one? I think. Yeah.
Oh,
cool.
Yes. Yeah.
Great.
Yeah, Vertica uses a bunch of different key sizes. Kind of depends on which one you're talking about. In terms of all TLS connections, there are a variety of key sizes you could use. That kind of depends on the cipher, which you can set, end users can set. For think the only one that we don't provide an override for is the AES encryption on spread, and that uses 256-bit keys, which should be more than sufficient. And everywhere else, like certificate key sizes are based on whatever users provide. So that's up to end users.
Got it. Thanks, Fen. Perfect. Okay. Got a couple others that have come in. Here's one. If I try to set up inherited privileges on views with roles, but my user can't select on other users' views, what are some troubleshooting steps? Chris or Fen, let's take that
So I can
one.
take this one, yeah. So this is similar to the previous one, right? Except now we've actually got past the initial problem. We're able to create views. And so we know that the user, hopefully through a role, is got the select privilege on all of those base relations. But this is where the only missing piece, the only difference between the creating a view and now letting other people select on it is that grant option for select on base relations, right? So look at those same system tables, right? Go back and look at the inherited privileges system table and make sure that not only does select show up there for the appropriate role or user, but that select star shows up. And if that's not there, that's your problem. If it still isn't working, it's possible that the grant option is coming through a different role. And finally, of course, you'll need to make sure that that user has that role as a default role. So you can check the user's system table to make sure. And that's really the only two things.
Okay, great. Thanks, Chris. Okay, we have another one here, and that is, do you have any good scripts for auditing security on Vertica?
Yeah, I can take that. So yeah, I have a bunch of different answers. It kind of depends on what you care about most. The management console, I believe, has several, or at least one dashboard, several dashboards. It has in there, you can track like failed logins and stuff like that. I believe that there was a talk at some point before this about DC tables. We have a lot of interesting and potentially useful stuff in those. We don't necessarily ship with the best support for running queries from within Vertica to identify security breaches, but tools like, I believe, I guess there are tools out there that you can feed Vertica data into, and they will try to identify issues with, security issues.
Yeah,
All right.
I would just
Well,
add
that's
that
good.
it really depends on the who's being, what's your auditing goal, right? What are you concerned about? What's your threat model? If you're concerned about users performing actions that they're not authorized to, there are event logs in Vertica that you want to look at to see, who's doing what. If you're concerned about unauthorized, network connections coming in from, places you don't expect, right? There's another system table for that. So that's all.
Great tips from both of you.
Yeah.
Okay.
Yeah, just to add to that real quick.
Sure.
As Chris said, it kind of depends on your threat model. It also depends on if you want proactive proactive alerts, then a tool outside of Vertica that is reading Vertica system logs is probably your best bet. If you want to diagnose exactly what happened, then Vertica system tables should provide everything that you need. And let us know if they don't, because we'd always love to add whatever people need.
Yep, absolutely. Great building on each other's responses here. The audience appreciates it. I think that's it for questions, unless someone has a late one they want to submit. Otherwise, we're getting to the end of the presentation anyway. All right, let's call it a wrap. And I want to give you some important information here. I want to thank the audience for your great participation. If we weren't able to answer any of your questions today, if any more come in, we'll do our best to respond directly via email. And again, our engineers, that's Fen and Chris and many others, will be in the developer lounge later. So make sure you attend the developer lounge, hugely popular. We've dedicated time at the end of the day and the day today, and then also tomorrow morning for a quote unquote breakfast. Please note that a replay of today's event and a PDF copy of the slides will be available on demand shortly. And of course, we invite you to share them with your colleagues. Again, thank you to our audience today. Don't forget to type the session code into the Analyze to Win section on the event navigation panel. Note that there will be a short message from our sponsors. I encourage you to stick around and catch. And now this concludes this breakout session. Have a great day, and we hope you enjoy Vertica Unify 21.